Hi, in this video we're going to talk about addition reactions again, but we're going to deal with something slightly different. Instead of homonuclear diatomic molecules like H and H or Br and Br like we did in the previous video, we're going to talk about heteronuclear diatomics and water. So in these, we're going to see the breaking of these double bonds, but we're going to need to determine what side is the H going to go on and what side is the halogen going to go on, or what side is the H going to go on and what side is the OH going to go on. And in order to know this, we have to invoke a rule, and it's called Markovnikov's rule. And we're going to add the hydrogen to the richest carbon. Okay, so let me write that down. Okay, H to the richest carbon. And that means the other thing is going to add to the other carbon, obviously. So let's take a look here. We have in our first example, 1, 2, 3, 4, we have butene. There's a double bond, so let's take a look there. That's our numbering. So this is going to be 1 butene. All right. Now, as we've seen, the HCl, or as we've seen, this reactant is going to add to that double bond. And we have one of two choices. We have either HCl there or HCl there. Okay, now we're going to learn how to apply this Markovnikov's rule. The H is going to add to the richest carbon. What do we mean by richest? The richest is most hydrogens. Okay, so looking at this carbon has 1 hydrogen right there. This has 2. This is going to be the richest. All right, so maybe I'll just try to darken that so we can see it a little differently than the one to its left. So that's going to be the richest. That's going to get the hydrogen. So crossing that out, it's going to add in this way. So that 4th carbon, CH3, CH2, we're going to have now CH with the Cl coming off of it, and we're going to have CH3. All right, now what do we have? Well, obviously we have an ane. It's going to be a butane. We have a chlorine off either the 2nd or the 3rd carbon. Well, obviously we want it the lowest number, so it's going to be 2nd. So 2-chlorobutane. All right, 2-chlorobutane. And remember, we're invoking this Markovnikov's rule. Hydrogen's going to add to the richest carbon, the one with the most hydrogens. So taking a look here, we have a cis configuration on this. Let's see, 1, 2, 3, 4, 5. Butene, or not butene, pentene, 5 carbons. Pentene, 1, 2, 3, 4, 5. So it's either 3 pentene or 1, 2, 3, 4, 5. So this is going to be the numbering, lowest number. So 2 pentene, and as we said, it's cis-2-pentene. Now we're going to add HBr, and we can add H here, or Br there, or H here, or Br there. Well, notice each of these carbons has only 1 hydrogen. These are interior carbons. They're secondary carbons. Remember from a couple weeks ago, these aren't terminal. They're not on the ends. In the last example, we were adding to one of the terminal carbons. But these are both interior. They're not on the ends at all. And as a result, well, it can add either way. So we're going to have a situation where it adds on the 3rd, and we're also going to have a situation where it's adding on the 2nd. Because there isn't a richest carbon. They both have 1 hydrogen. So it can add either way. So in this case, we're going to have 2 products. in appreciable equal concentrations. And in either case, we have to name them. They're both pentanes, but on the top we're going to have a 3-bromopentane. Then this one on the bottom is going to be 2-bromopentane. All right. Now let's move away from the hydrohalogenation to, all right, hydration, adding water, hydration. And in these, we have to pay attention to water, HOH, H2O. So one side's going to get OH and the other side's going to get H. All right, so now we have to apply Markovnikov's rules to this same process. In this case, with water and a lot of acid, we can break this double bond on 1, 2, 3, 4. This is 1-butene again. All right, 1-butene. We're going to break that double bond, and we can have either H add to this side and OH add to this side, or H add to this side and OH add to this side. But let's invoke Markovnikov's rule and take a look. What is going to happen here? Can we add the H this side? No. This is not the richest carbon. This carbon has 2 hydrogens. So the lower situation alignment is going to be the one that occurs. We're going to have H bond to this carbon, and we're going to have OH bond to this carbon. And thinking about OH, we're going to make an, yep, you guessed it, an alcohol. So we have a butane here. We went from a butene to a butane. All right, but remember we have an alcohol, so it's going to be a butanol, and we can number from left 1, 2, 3. This will be the 3rd carbon, or we go from the right 1, 2. It's going to be 2. All right, 2-butanol. We want the lowest number, remember. Finally, going back to the cis-2-pentene. We're going to hydrate this bond with a very strong acid, breaking this. And with Markovnikov's rule, again, we don't have any preference to either side, so we're going to get the 2 kind of products. So we're going to have H add to this side, OH add to this side, and then on some OH add to this side, and some OH or H add to this one. So we have to draw 2 products here. So let's see, CH3, CH2, CH with the hydroxyl group, CH2, CH3. Sorry about my bad writing. Or we'll also get some, I shouldn't say or, we'll get and. It's not or, it's and. We're going to get both, a mixture of both. CH3, CH with an OH there. CH2, CH2, CH3. So this top is another, this is a pentanol, 3-pentanol. Okay, 3-pentanol, and in this case, 2-pentanol. All right, so remember the interior carbons, if the double bonds on an interior carbon, Markovnikov isn't telling us which one it's adding to because they're both equivalent. And as a result, we're going to get a mixture of both products, whether it's hydration or hydrohalogenation. All right, so dehydration. For this, we're going to lose water. All right, we're going to lose water. And obviously, the OH part of water is going to come from this alcohol. Now the question is, where is the hydrogen going to come from? Is it going to come from the terminal carbon, or is it going to come from this interior carbon? And Zaitsev rule is going to tell us that in fact it's going to come from this interior carbon. This is the hydrogen, one of these hydrogens right here is going to be pulled off bond with the OH giving us water, and we're going to form a double bond right here. It's not going to be the terminal carbon, okay, not the terminal carbon. So when we do this, we form water. Don't forget we're forming water, and we're going to form 2-butene. And what was this molecule here? 1, 2, 3, 4. We have a butanol, 2-butanol. Okay, 2-butanol. Just like we had in step 3. So it's kind of interesting. As you can see in question 3 here, we have the double bond on the terminus, on the terminal carbon here, and we add water and we get a 2-butanol, but when we dehydrate 2-butanol, it's going to give us a 2-butene. It's not going to want to form that double bond on the terminal carbon as it had formed from in a kind of like the opposite direction because of all the electronic properties of carbon, withdrawing groups, etc. So anyway, that's how you do dehydration.